On the 5th of August, 2026, a piece of a SpaceX rocket hit the moon at more than 5,000 miles an hour. It had been dead in space for 18 months. Nobody steered it. Nobody stopped it. A telescope in the Chilean desert measured sodium and lithium in the ejecta. A Korean orbiter photographed the site 8 separate times. NASA put the crater at about 60 feet across and 12 feet deep. It was, by any measure, the best observed artificial impact in the history of the moon, and it produced no answer to the question a room full of scientists in 1969 would have asked first. Not how big, not how bright. How long did it ring? Because we know the moon rings. We've known since November 1969. We just stopped being able to hear it, on a specific day, for a specific reason. And it wasn't a scientific one. Apollo 11 left a seismometer behind. It ran on solar cells, it recorded somewhere between 1 and 200 micrometeorite strikes, and it died on the 27th of August, 1969, 31 days past the end of its design life. A first look and nothing more. Apollo 12 brought the real thing, a plutonium-powered station called ALSEP, set down on the ocean of storms and switched on while Pete Conrad and Alan Bean were still standing next to it. And then, NASA did something that sounds insane until you understand why. On the 20th of November, 1969, with the crew safely back aboard the command module, Mission Control dropped the empty lunar module, Intrepid, onto the surface, deliberately, a short distance from the instrument they had just finished installing. The logic is simple. Strike a body with a known mass, at a known speed, at a known spot, with something on the ground listening, and you can read the shockwave backwards to work out what's underneath. It's the same trick geologists use on Earth with dynamite. The reading came back wrong, not weak, wrong. On Earth, a seismic event has a shape: sharp arrival, peak, decay. This one built slowly, peaked several minutes in, and then took the better part of an hour to fade, 55 minutes. Maurice Ewing of Lamont Observatory reached for the only comparison that fit, as though someone had struck a bell in a church belfry, and the sound had simply kept going. 5 months later, they did it again, harder. Apollo 13's third stage, about 15 tons of spent Saturn V, was aimed at the moon even after the mission had already fallen apart. It hit at more than 5,000 miles an hour, with the energy of roughly 11 tons of TNT. The signal lasted 3 hours and 20 minutes, and it arrived so strongly that controllers had to send a command to the moon to turn the instrument's sensitivity down, just to keep the trace from running off the edge of the page. Here's the answer, and I'd argue it's stranger than the theory that grew out of it. Earth damps sound. Our crust is warm. It's chemically wet. Water bound into the rock itself, and it's relatively intact. A shockwave moving through that loses energy fast. It gets absorbed. The moon does none of that. It is bone dry. It's cold. And 4 billion years of unshielded bombardment have left the outer crust shattered. A layer geologists call the megaregolith. Broken rock stacked on broken rock, kilometers deep. A wave entering that doesn't travel cleanly, and it doesn't get absorbed. It scatters off every fracture, every boundary, every buried block, over and over, arriving at the seismometer not as a clean pulse, but as a long smear of energy that takes hours to die. Now, if you've heard about the moon ringing before this video, there's a good chance you heard it attached to something else. In July 1970, 2 members of the Soviet Academy of Sciences, Mikhail Vasin and Alexander Shcherbakov, published an article titled, "Is the Moon the Creation of Alien Intelligence?" Their argument was that the moon is a hollowed-out planetoid, an ancient ship with an armored inner hull, and they pointed at exactly this data. It rings, they said, because it's empty. 2 things worth saying plainly, because this channel doesn't do it any other way. First, it wasn't a scientific paper. It ran in Sputnik, a Soviet popular magazine, closer to Reader's Digest than to Nature. Second, the data killed it. Deep moonquakes are recorded hundreds of kilometers down. Inside the volume, the theory needs to be empty. And in 2012, NASA flew 2 spacecraft in formation around the moon and mapped its gravity field precisely enough to weigh the inside of it. There is rock down there. The real explanation isn't a hole, it's rubble. The network grew. Apollo 12, 14, 15, and 16 all left stations behind. For 8 years they ran continuously, nuclear-powered, transmitting home every single day, cataloging thousands of events on a world nobody was standing on. And then, on the 30th of September, 1977, NASA sent the shutdown commands. Every station. One day. There was no failure. Most of the instruments were still working fine. There's a document, NASA reference publication 1036, the ALSEP termination report. And the reason in it is the most ordinary reason in the world. Money. It cost a few $1 million a year to keep listening, and it was cut. The seismometers are still there. They've been sitting on that surface for 49 years. They just aren't switched on. Jump forward. In March of 2015, a sky survey in Arizona picked up an unidentified object in a wide, looping orbit and gave it a catalog designation, WE0913A. Nobody knew whose it was. One of the people tracking it was an independent astronomer named Bill Gray, who writes the orbit calculation software much of the amateur community runs on, and who tracks objects the military doesn't bother with. In late 2021, he worked out that WE0913A was going to hit the moon. The best fit at the time was the upper stage of a SpaceX Falcon 9 that had launched a NASA climate satellite in February 2015. That's what the headline said, worldwide, for weeks. A SpaceX rocket is about to crash into the moon. Then, Gray revised it. Further observations didn't match the Falcon 9's path. They matched a Chinese Long March booster from the Chang'e 5T1 mission, launched October 2014. In February 2022, China's foreign ministry stated the object wasn't theirs, though the mission its spokesperson named was a different one with a very similar name. Gray's own read is that it was an honest mix-up. Then, Gray revised it. Further observations didn't match the Falcon 9's path. They matched a Chinese Long March booster from the Chang'e 5T1 mission, launched October 2014. In February 2022, China's foreign ministry stated the object wasn't theirs, though the mission its spokesperson named was a different one with a very similar name. Gray's own read is that it was an honest mix-up. When the Lunar Reconnaissance Orbiter finally photographed the site, it didn't find a crater. It found 2, side by side, roughly the same size, about 90 feet across together. None of the Apollo boosters ever did that. A 2023 analysis in the Planetary Science Journal worked out why. The object had been tumbling in a way that only makes sense if it carried a second mass at the far end, counterbalancing the engines. Something was bolted to that rocket. It was never declared, and it's on the far side, so nobody has been to look. On the 15th of January, 2025, a Falcon 9 lifted off from Kennedy carrying 2 commercial moon landers, Firefly's Blue Ghost and iSpace's Resilience. Both got where they were going. The upper stage that delivered them did not come home. It ran out of fuel. It was never commanded to steer clear of the moon, and it spent the next 18 months in a wide, drifting orbit, pushed around by solar activity and gravity. On the 29th of April this year, Bill Gray, the same man again, published a prediction. Not just that it would hit, the date, the time, and the place, near Einstein Crater, on the western edge of the visible disk. He was right. On the 5th of August, about 4 tons of dead rocket hit the moon at over 5,000 miles an hour. Nobody actually saw it. It hit sunlit ground, so there was no flash to catch from Earth. but the European Southern Observatory's Very Large Telescope in Chile detected sodium and lithium emission from the impact, glowing for 5 to 10 minutes after the strike, and South Korea's orbiter, Danuri, started watching 30 minutes before the collision. So, we predicted it 4 months out. We read its chemistry from a mountaintop in Chile. We photographed it from lunar orbit 8 times over. We know its mass, its speed, and the exact coordinates it struck. That is precisely the experiment Apollo scientists spent an entire program trying to arrange. Known object, known velocity, known place, and there was nothing on the ground to hear it. Not one working seismometer has stood on that surface since 1977. The 2022 impact, the 2026 impact, every hard landing in between. The moon may have rung for hours each time, and the only instruments that could ever have told us have been switched off for longer than most people watching this have been alive. Later this year, that changes. 2 seismometers, one French, one British, riding an American lander down into Schrödinger Basin on the far side. The most sensitive instruments ever placed on another world's surface. The first ears ever put on that hemisphere. They'll be listening for moonquakes and meteorites. But the thing I keep coming back to isn't what they're going to hear. It's the 49 years of it we already missed. The moon has been ringing this whole time. There was just nobody home. Real cases, sourced facts. Sources are in the description.